My name is Dean Weber. I'm the CTO at Mocana. Mocana builds a platform of security for IoT devices of all sizes and ranges. Our concept is that we build it from the ground up. We use those trust anchors. Personally, I was on the development team for the TPM 1.0. I'm a signatory on the design. These are things that hardware, firmware, software-based roots of trust are the elements of security that you base your security posture on. And you can do that in hardware, you can do that in software, you can do that in firmware, and all of that should be against a measured element. All of that can be developed in a way that works together and ties together and is able to convey trustworthiness in the form of a communications path to elements that are outside of the individual item that we're trying to protect. Obviously, targeted industrial attacks are occurring and have occurred and will continue to occur because we have lots of vulnerabilities in our industrial markets. And that's every industrial market. That's not just cellular, that's not just 5G, that's not just future state. That's every market that's out there has vulnerabilities. There are multiple vectors to defend against. When you think about where an IoT device is, the slides that the gentleman before me had up are a great depiction of how a device sits in a framework. That device communicates to an upstream controller, which connects to an upstream communicator, which then connects to a back-end data service, which then connects to a group of programmers associated with the operation and design elements of that platform. So there's lots of places here where you can get into these devices. Not all of it's in your direct control. Hackers are bypassing our defenses, right? The defenses that we're using today are primarily in the IT space, at the edge of the industrial networks. And the industrial networks themselves are, needless to say, not going to listen to all the things that the IT brethren are going to tell it. People are going to bring in devices from outside. They're going to do programming on the OT networks. They're going to bring in updates. They're going to do all kinds of things that are going to bypass those perimeter defenses, which again is why we want to build security in. We don't want to bolt it on. Do you want to have a firewall at the edge? Of course you do. That's another defense in depth object. But that's not going to secure your device. And that's not going to secure the data that is being generated by your device. Those are things that have to be done. All of these require some form of security. And security elements can be built on top of one another. You can have a root of trust. You can have a trust measurement. You can have a secure transport. You can have a discrete, strong identity associated with the platform or with the transport or with any of the functions that are associated with modern industrial computing. Each one of those elements can have their own little piece of the pie. And then you have to stitch them all together in order to make a comprehensive solution. Industrial OEMs today are trying to do exactly that, right? So the customers that are ours, our Mocanas, are the builders of that equipment. They're the PLC manufacturers. They are the DCS equipment providers. They are the ICS SCADA operators who are operating as a service through their management of their platforms. All of these elements have to have a component of development of the platform and then onboarding that device once it reaches the network, and then enrollment of that device into some type of authentication and authorization domain. That may be encryption, that may not. And then updates and management, right? So again, to the point earlier that you have to keep updating these platforms. One of the big things in IoT, and specifically industrial IoT, is that these devices are not being patched. And they're not being patched for a simple reason. You can't get to them securely. Opening up a patch venue to those devices opens them up to extreme manipulation. So what do? You build a comprehensive end-to-end security platform. That's what Mocana does, right? So what we're talking about here is, this isn't vaporware, this is what we do for a living, right? We build libraries, we build platforms, we build management structures associated with managing those elements. The integration on all kinds of devices, whether it's a low-power chip or whether it's a full-blown multi-core chip, doesn't really matter. It depends on what its function is. And if you go look at some of the industrial standards, that's where the rubber really hits the road, right? How do you make a claim against a standard if you don't have the underlying element to make the claim with? The outcome of this is a compliance objective. Better security. How do we do that? How do we answer the bell on 62443? Or how do we answer the bell on NIST 853 R4, soon to be R5, right? These are the elements that have to be built in order to make those claims. If you don't do those things, then you're not going to win this game. You're going to fail at your compliance objectives, and at the end of the day, you're not going to be competitive in your market space. So Mocana does an end-to-end protection model where we start at the endpoint. Again, all those secure elements that we talked about earlier, could be hardware, could be firmware, could be software. There's actually measurements associated with them in some of those compliant objectives. 62443 3-3 says, pick your target and then figure out what it is that you're trying to defend against. Is that a young man in a darkly lit basement living in his grandmother's house? Or is that a near-peer nation state with unlimited resources that's coming after you? So once you pick what you're trying to defend against, then you can pick what level of security you need. How much security is enough? How much security is just right? Those are the kinds of questions that need to be answered if you're going to pick a cost-effective solution at securing your industrial environments. That's what has to happen. And that's the way that those elements are doing. It's a risk assessment, it's a validation of that risk against a risk profile, and then it's pick what security you need. And again, picking something simple like roots of trust. A software root of trust is relatively easily manipulable. Depends on its environment, depends on how you protect it, but at the end of the day, it's relatively easily to attack that root of trust. Whereas at the other end of the spectrum, a TPM is almost impossible to attack because it's written in firmware. It's written in firmware inside a dedicated chip that is inaccessible. Those keys are not public in any way, shape, or form. And everything in between, right? PUF, TEE, Trust Zone, eSIM, SIM technologies, all of these are different forms of root of trust, and you probably have many of them in your environments. At the end of the day, what we need to do is we need to start with those devices. We need to build trust models around them, because at the end of the day, if you don't protect the device, how do you know the data that the device is generating is any good? And then if you don't protect the data that the device that you now know is good is generated, how do you use that in a decision support role? Right? How do you know that the fact that you're asking for a water measurement and a water table in a vineyard, right? And at the end of the day, your competitor says, well, we should tell them that they need more water, even though we just had 4 inches of rain. Guess what you're doing? You're putting your competitor out of business. Something very simple, like a little tiny piece of data. So these are the things that we need to start thinking about when we talk about in terms of levels of protection. And then we have to bring it up through those devices that generate that data. We have to get it to those decision support systems. How are we going to do that? We're going to have gateway systems. We need to confirm them at the same level of the devices that are generating the data because they're an integral part of the data path. Okay, so a comprehensive solution looks like this. There's the integration, there's the provisioning, there's the management. Components of each of those, some are going to sit on the endpoint, some are going to be part of the management and data planes. Some of those are going to be outcome-based. Where do you put the logs? Where do you put the data that you've collected? Those are all things that have to be considered when you're truly looking at an end-to-end solution. So in the provisioning model, there's a number of elements associated with what that takes to do. So you have to have some level of identity that you're chosen to use. You have to be able to provision that identity to the devices that you are trying to use as elements in your network, so that you know what they are and you know what their relative posture is. And then you have to be able to manage those functions, right? Those certificates expire. Worst case environment. The United States government's been saying SHA-1 has been broken for over 10 years. Stop using it. Do a search of the internet using various tools to find out how much SHA-1 still exists out there. Largest single offender, the United States government. Why is that? Because they can't get to those certificates. They have no mechanism. They lost the keys. The stuff's so old they can't get there. So you have to start thinking about management in longer terms, about how am I going to refresh my certificates? How am I going to be able to change my algorithm so I have cryptographic agility when we start talking about things like pre and post quantum? These are all things that are coming at us, and they're coming at us fast. So these are the kinds of things that you need to put into your design specification, and you need to find partners that are able to provide those types of solutions. So this is what we do. We have an endpoint solution, a whole slew of operating systems from headless and embedded all the way up through modern RTOSes were embedded in VxWorks as an example. These are all functions of an operating platform that can use a root of trust that then are able to convey that trust through a connection. The centerpiece of this is the management of all of that. How do you manage those certificates? How do you manage those elements of trust that you are deploying in your environment? And maybe it's not certificates, maybe it's PKI, maybe it's PKI natively off of an HSM. There's lots of different mechanisms out there. Maybe it's an LDAP domain, right? That's not a certificate. That's a cryptographic function associated with a domain operation. In Microsoft's case, that's Kerberos. How do you use any of those elements when you're talking about a comprehensive security solution across the environment? It's not just about X509. It's not just about PKI. It's not just about Kerberos. It's about an important end-to-end solution that takes into consideration all of those elements and how do you orchestrate those elements. That's what Trust Center does. And then you have all the back-end functions, right? And you need to be able to connect to them. When we start talking about supply chain, we start talking about how do you validate the supply chain in an industrial environment. Well, you know, we've already got requirements for code signing. United States government says 800-171. ISO IEC 62443 4-2 says you have to sign all your code. You have to validate it. What do you do with that? You got a key and you got a hash. How do you put that to work for you? Well, you need to make sure that that's part of your trust chain. When you build a trust chain, you need to take those elements and endorse them into larger elements. So you take the hardware sign, the root of trust key. You take the next piece, the BIOS measurement. You take the platform measurements, the OS measurements, the application measurements. All of those are signed elements. And you stitch them together to come up with a value that says, here's why I'm trustworthy. This is the trust value for me. I am trustworthy because I have all these measurements. And if something goes wrong, you can go right back down to the element that showed you what was wrong. This is protection, not detect and respond. This is a change in the paradigm about how we think about security. And we in the OT markets have the ability to do that today. We can change the paradigm. We don't have to follow the mistakes of the IT world. Because the IT world made a lot of mistakes, and they're still paying for them today. Right? I wouldn't call the IT environment anything like secure. So what do? You build security in, and you build it in such a way that it is conveyable, that it is communicable, and ultimately it is able to be used as a forensic tool to tell you what is in the platform. And then you provide a management sphere around all of that, and you have to make sure that that scales, because potentially we're talking about hundreds of thousands or millions of devices. Right? When we talk about commercial IoT, we talk about the potential for lots and lots and lots of devices. How do you do all that? You have to have a platform that scales to the management structures of those types of operations. So you got to be able to manage certificates at group levels. You got to be able to manage Kerberos ticketing functions at the group levels inside the domain architectures. These are all things that have to be done if you're going to make this a successful end-to-end solution. When your software developer builds their stuff, they send it off to the device manufacturer. The device manufacturer sends it into the platform, creates a trust chain. That trust chain, that change of ownership from the OEM to the consumer or the operator happens. How do you do that? Because that's another signing, right? That's another endorsement of the key set. So we've got the developer, we've got the platform builder, and then we got the consumer. All of those are part of your trust chain. How do you manage all of that? That's what Trust Center does. So the benefits are only provisioned devices are going to be able to communicate in this environment. You're going to know, beyond a shadow of a doubt, that the things that you're communicating with are trustworthy. And if they're not trustworthy, you're going to know where they are, what they're doing, and how do we address them. And you're going to know, when you address them, what part of the system failed, if any. Because if you do this right, if you actually take this all the way out to the transport levels, literally only trustworthy devices can talk to trustworthy devices using remote attestation. And we engender and enable all of those functions, both from a management standpoint as well as from an endpoint standpoint. Okay, so comprehensive IoT, we can do all of these functions. We can do device integration, we can do provisioning for all of these functions, we can do management on all of these functions. We can also protect brownfield devices. We have elements that you can deploy on brownfield devices that don't necessarily have the ability to create a brand new stack. devices that are low in processing power or low in memory. We have binary agents that we can deploy on those. They're not as strong as building it from the ground up, but they're a heck of a lot better than nothing. So again, all of the legacy devices that are out there have other problems, right? They have space problems, they have age problems, they have identity problems. You know, we were just talking about this earlier today. Old compact and control logics, Allen Bradley PLCs, don't even have a username and password. If you know the IP address of the device, you can manage it. That's scary when you think about where PLCs are used. Okay, so we accelerate the compliance initiatives. We provide components to compliance elements in each one of these aspects. We serve the global industry OEMs. Those are some of our customers and what they do with us. You know, some of us are using for compliance objectives. Some of us are using for securing legacy devices. Some of them are using for next generation industrial gateways. This is our partner list, and rather extensive. Again, Mocana's been around a pretty long time, 2002. Our customer list and our brag slide about who all we do business with. We do business with 200 of the Fortune 500 industrial manufacturers. So at the end of the day, come and visit us. We're at a booth here on the floor, or reach out to us, and I understand we're going to make slides available. So I thank you for your time, and I hope this was informational.